Okay. And before we actually officially say the pattern of where the vertex comes from, we're going to sort of review what you did in 4.3. When you were working on that math lab in 4.3, you were either using your graphing calculator or Desmos to figure out a lot of values. So the first thing that I am going to get you to highlight on the next page is this title, The Effect of Changing the Value of Q. And you don't have this table, you just have the graph, so that's what we're going to look at. Did you notice in 4.3 when you were graphing a bunch, if you change the number at the end, your graph went up or down, right? So if I had y equals x squared plus 2, I'd be like, well, here in the solid line is my regular x squared graph, and in the dotted one, it got shifted up 2. And if I had x squared minus 3, that would take my regular parabola and move it down 3. And in fact, we have a whole unit. How many of you are taking grade 12 pre-calculus next semester? Good. Good. If you are in grade 11, you should be finishing grade 12 pre-calculus by the end of grade 11. That is sort of, if you're taking pre-calculus, that's the plan. So some of you, if you haven't registered for grade 12 pre-calculus next semester, you might want to see if you can change your schedule. That way you have an opportunity to see university level math in high school, which is really nice because it gives you, it's not that learning in university is hard, but you see our class is what, 20 people, 25 people, compared to first year university calculus, sometimes you get 150, you go to bigger university, 300 people in the class. That's insane. So you don't get the ability to ask as many questions and get as much help. So that's why it's recommended by the end of grade 11, you get done your grade 12 pre-calculus. Some students then in grade 12 go, grade 12 pre-calculus was so hard for me, I want to take it again. Some people go, I definitely want to take the advanced math and the calculus and the AP calculus and get first year university under my belt so I'm ready for it. Perfect. Some people are like, I did pre-calculus, I don't want to do calculus, but I want to keep my math skills up. In grade 12, I'm going to take a grade 12 applied or grade 12 essentials class. So I have another credit in math. But all of that is the plan to be finished grade 12 pre-calculus by the end of grade 11. So, one of our units in grade 12 pre-calculus deals with this idea that if you add 2 at the end of your graph, it just moves it up 2. If you subtract 3 at the end of your graph, it just moves it down 3. This works with lines too. If you have a line y equals x, and you subtract 3, it moves it down 3. The next thing that we noticed, second thing to highlight. Oh, I've got it right here. Here we go. The effect of changing inside. And you would have noticed yesterday that if you had an x minus 2, it moved it not 2 to the left. You would probably want it to move it 2 to the left, so you see the minus 2, but it moves it the opposite way, 2 to the right. And the reason for that is really easy to see if we think about the vertex. Can you see that on your regular y equals x squared, your vertex is at 0, 0. Now, I have x minus 2, my vertex is at 2, 0, not negative 2, 0. And the reason it moves 2 to the right and not 2 to the left is we are trying to find the x value that still makes y 0. What would you have to plug in for x to make it equal to 0? You'd have to plug in the opposite, positive 2. And so that's why it moves it to the right. Same thing here. What would you have to plug in to make this 0? You'd have to plug in -3. And our new vertex is right here at -3, 0. So the number inside moves it left and right. The number outside moves it up and down. When we look back at the ones we started with, can you see this one would move 1 to the right and 2 up? Look at our new vertex. If you moved 1 to the right and 2 up, there's your new vertex. 3 to the left and 6 up. There's my new vertex. 4 to the right and 7 down. There's my new vertex. Just 5 up. You see there's nothing with the x squared. So the x stays at 0, and the only thing is it was moved 5 up. So there's my new vertex. Here, 8 to the right, but not moved up or down. So you get 8, 0. 2 to the left, but not moved up and down. -2, 0. And finally, 9 to the right and 1 up. So the hint in the vertex is based on how it's moved left, right, up, and down. Now there's another thing that changes our graph. The next thing that we're going to highlight, which is the number in front. And the number in front makes it either narrower or wider. Technically, the proper term would be that it stretches it vertically away from the x-axis. So if my a value is 2, highlight this one right here, y equals 2x squared, it's stretching it away from the x-axis. And if I stretched, like, I don't know, think the parabola is made out of spaghetti and you pulled it up, can you see that that would make it narrower as you pulled it up? And if you pushed it down, took that spaghetti and pushed it and compressed it towards the x-axis, it would make it wider. So one of the things that math teachers tend to do with parabolas is they talk about narrower and wider because it makes sense to talk about that. But it actually, in a bit, messes you up for grade 12, because in grade 12 we don't want to talk about narrower and wider. We always want to talk about stretching or compressing. Okay? So since we're only dealing with parabolas, we tend to be like, well, the nicer words are narrower and wider, instead of stretched vertically and compressed vertically, because your mind sees narrower easier than it sees stretched vertically. Your mind's like, that doesn't, it's not a word that I use. Like, ooh, the road up ahead is really stretched vertically. No, it's narrow. So we have these problems with language, that we want to use language that makes it easier in one sense, but it sort of holds us back later on. So I'll try to do both, okay? So we would say this one is narrower because it's been stretched vertically. Our pattern, do you remember this pattern? On the x squared, I'll do this one in red. Over 1, up 1, over 1, up 3, over 1, up 5. 1, 3, 5. Okay? When you have a 2, I'll do this in green. It goes over 1, up 2, over 1, up 6, over 1, up 10. So the 1, 3, 5 pattern got doubled. And it got doubled because it makes sense. If you stretch something vertically, you're timesing it by 2. If I had 1, 3, 5 vertically and I doubled it, it makes sense that I would get 2, 6, 10. And here, compressing it by half, if I had 1, 3, 5, now with the half, I have 1 half, 3 halves, 5 halves. It's been cut in half as well. Next thing we look at is what happens if you involve a negative. Oh, and I probably have something to highlight. Oh, is there nothing to highlight on this one? 278? No, they just included it in the A value. So if I have a negative in front, it flips it. And before I was able to tell if something was a minimum or a maximum, and I asked you if you could find the hint for that, right? Notice that the ones that have a negative in front, flip that parabola down, would make sense that your, this is good imagery, vertex would be a maximum. Whereas if it's not negative, your parabola opens up, then your vertex would be a minimum. So we have 1, 2, 3, 4, 5 of these that have, I'm going to add that plus sign in front. Yeah, you see that all of those ones are positive. And these were the ones that were negative. So the negative ones, your parabola's down. Positive ones, parabola's up. So we're going to put all of this together. Is it up or down? Is it narrower or wider? Where's the vertex? How has it moved left and right, up and down? And we're going to be able to graph all of these. So here we have a negative. Here we have the negative with the 0.5. And with the negative, the rule of over 1, down 1, over 1, down 3 would happen the same. So look at this one. When I do these, you see I went over 1, down 2, over 1, down 6, over 1, down 10. So my 1, 3, 5 got doubled, still like normal, but it got flipped. So now it's over 1, down 2 instead of over 1, up 2. And putting this all together is what we have and what is called the standard form. And depending on what textbook you have, there's 2 letters that people like to use for the standard form. Our textbook likes to use P and Q, right? But if you're helping your friend and they're taking, I don't know, French immersion uses P and Q, or you're helping a friend that uses a different textbook than you, this other letters are sometimes H and K. Don't know why. But it's almost universal that it's either P and Q or H and K, and it really doesn't matter. This is our formula sheet. Hopefully our formula sheet has P's and Q's, because our textbooks had P's and Q's. Or does our formula sheet not have this? Oh, it does have P's and Q's. Right? I just wanted to show you the H and K, in case you were like somewhere else, you're like, I don't know how to do this. These letters. Do the letters really matter? No. They could have used B and C, because they're like, oh, what comes after A? B and C. Although they tend to not want to use B and C for this reason, because in your quadratic formula, remember you have this for the quadratic formula? This has a B and a C, and an A. And it just so happens that this A always matches this A. But the B and the C turn into different numbers, so they're like, well, we can't use B and C again, because now they're different. So that's one of the reasons why the letters aren't B and C. That doesn't really matter. The important thing is, do you see the pattern? We've done it already, that your vertex will be whatever the opposite sign is of the inside, because the inside moves it left and right in the opposite direction than you see. It will always be the Q value, because that moves it up and down exactly as you see. So that will always be your vertex. We draw a dotted line through the center of our parabola to show that it's symmetrical. This dotted line has a name. It's called the axis of symmetry. And all of these definitions are going to be important because you're going to be asked to give characteristics. They're going to say, what is the vertex? If you don't know what vertex means, you're screwed, right? I should do that once. I should see, how good are you at math if I make up new words you've never heard before? Right? And I say, you know, in the following graph, find the apricot. You'd be like, I know what an apricot is in real life, but I have no idea what it means in math. Could you answer that question? You'd be guessing. You'd be like, is the apricot the vertex? Is the apricot the axis of symmetry? Is the apricot whether it's a maximum or a minimum? I don't know. Right? And I know that students are in this situation all the time. You get tests. You read a word, and you're like, I have no clue what that word means. Right? So it's really important as we see these things that we take a moment while we're learning it for the first time to try to like, how am I going to remember that? Right? And if you feel like at the end of the day, you know, you're walking out, what did I learn in math today? I'm like, I don't remember what that's called. You should look it up quickly again, instead of waiting to a quiz or waiting to a test. Because as soon as that becomes part of your vocabulary, then you're able to answer questions easily. Now, I'm not going to, congruent means the same. The word congruent means it's the same. And when they're talking about something being congruent, it's the same width, either narrow or wide. So x squared plus 5 is just moving your x squared graph up 5. We would say that those two are congruent because they're the same shape. But x squared and 2x squared, one is wide, one is normal, and the other one got narrower, we would say those aren't congruent. So all of that is the introduction so that we can find, yeah, here's the one that, this graph here. In fact, you can now write the equation. Check this out, this dotted line. Would you agree that it looks congruent to the x squared? The same width. It goes over 1, up 1, over 1, up 3. So that tells me my a value, I'm going to write it in, but I don't need to, is a 1. The vertex is at negative 1, 4. So it's moved 1 to the left and 4 up. And I just wrote the equation for that dotted line, knowing the patterns. It has to be a positive 1 because it's opening up. It's a 1 because it's the same width as my regular x squared graph. Goes over 1, up 1, over 1, up 3. Oh, and I wrote the vertex wrong. Thank you for pointing that out and being so kind. It only went up 3. Apparently I can't count this one. Where I got tempted. Do you ever find yourself? Like, I was counting 1, 2, and I was like, oh, there's the number 4. Isn't that a nice looking number 4? And I got tempted and I wrote that number 4. Math does teach you to be careful, because if you're not careful, things go awry. So here's a graph. From this graph, we can see that we've gone over 4, down 2. I'm going to label that vertex as 4, negative 2. I actually get a little frustrated with the textbook when they play tricks on us like this, because can you see yourself being tempted to write over 4, down 1? And then they went and put the scale by 2s on our y-axis. That's not very nice. Like, I know what I'm doing. Why are you tricking me this way? So again, be careful. Double check your scale, right? textbook will do this when they make their questions. So I know my vertex, and what happens when I check the over, down? Over, down, over, down. We go over 1, down 2, over 1, down 2, 4. Did I miss one? Oh.
It barely doesn't go.
Went over 1, down 2, and then over 1, down. Oh no, it's not. I've messed it up. You see that it's here that it hit? Oh. Over 1, down 3, and then over 1, because that's at 5, down to 14 would be down 9. What would we have to, okay? And this is a good example. I'm going to show you two things that we can do with this example. I did the shortcut method and screwed up royally to begin with. Because I went over 1, down 2, because that's what it looked like. And then when I went over 1, down, it was supposed to be 6, and it wasn't matching up. Because remember, the normal pattern is the odd numbers. And our graph here had over 1, down 3. Yes, technically it's negative, and then down 9. So you notice that our normal pattern has been multiplied by 3. In our equation, then, we will have a negative 3 first. Where's our vertex? 4 to the right. And 2 down. Here is our equation. A better way to find A. Because can you see yourself screwing up in counting? And over 1, down 2. And what happens if A was like over 1, down 4.32? Right? You'd be like, I can't tell exactly. And it could be that it could be decimals like that. So the over 1, down 1, over 1, down 3, over 1, down 5 is great if the numbers are nice. It is a shortcut. But with all good shortcuts, they don't always work. And if you don't have a better way, then you might get it wrong. So the better way to find A is to use algebra. What we know, and we plug in, since we know the vertex, we know that our equation is going to look like this. That's our equation without knowing the A value. Then we choose a point other than the vertex. We make the mistake of trying to do something on our smartboard. And the reason we don't choose the vertex is if you choose the vertex and plug it in, 4 minus 4 is 0, and your A value will get destroyed. I wanted to say obliterated or something, but the word was not. What? Obliterated, yeah. A value gone. And then you can't solve for it if it's gone. But we have another point. We have a point. Let's choose this one right here. This one is at 2, negative 14. That was given to us. There was a little big red dot at that point. So we know that point for sure. What we can do is we can plug it in. When y is negative 14, x is 2. And you make an equation where there's only one thing you don't know. you don't know A. And so now it's just a matter of doing the math
Sorry
like
for the
you've done.
interruption. Grade 9 students that have the last name that start M to S and needing a picture retake, please make your way down to the library. That's grade 9 students with the last name that start M to S that need a picture retake. Please head down to the library.
So now you just have to be careful with your like grade 9, grade 8 equation solving, right? I want to get A by itself. Order of operations, can you see that this whole thing would be -2 inside the bracket? Squared would be +4. How do I get A by itself? I would have to add 2 to both sides. That will give me -12 equals 4A. Divide both sides by 4. And I get A is equal to 3. We found that with the shortcut eventually, but screwing up first. See, here's my A value. It's -3. The algebra finds it perfectly. The algebra would find it even if it was a not nice number. Like if the A value was 2/7. Not really easy to see that counting-wise. None of the points would match up, and you would be stuck. So if you rely only on the shortcut, you're not going to be able to get some of the more difficult. Even this one, right? I screwed up originally on the shortcut because I thought it was over 1 down 2. I didn't look at it carefully enough. The scale wasn't nice. Okay, so here's our first question. I would like you to try questions 3, 4, 5, and 7.